All right, so let's dive into the world of James McClelland. We've got this awesome article about him. And, you're into AI, so
Yeah.
we'll be looking at how his work shaped the AI we see today. Basically trying to figure out
Right.
how we went from like AI that just follows rules to,
Yeah.
the AI we have now that can learn.
Yeah. It's a wild ride.
It is.
So like way back when
Okay.
symbolic AI was like the main thing. It was all about
Right.
rules. Like imagine a computer with a huge set of if-then rules, It worked okay for some things, but then
Yeah.
you throw in like the real world and everything gets messy
Yeah.
and it just falls apart.
So it's kind of like
Yeah.
if you had a chess program that was awesome at chess,
Right.
but you try to tell it a joke,
Exactly.
and it's like, what?
Yeah, that's the brittleness problem they had with symbolic AI. Couldn't handle anything unexpected.
Right, okay, I see. So that's where McClelland comes in.
Yeah, he was like, hold on. The human brain doesn't just follow rules, right? It's more about how all these simple units, kind of like neurons, work together.
Oh, okay.
And that's what connectionism is all about.
Okay, so instead of just rules,
Yeah.
we're talking about networks of like...
Yeah, interconnected units, yeah.
Okay, how does that make AI like...
So think of it like this. With symbolic AI, all the knowledge is in specific symbols.
Right.
But with McClelland's connectionism,
Yeah.
the knowledge is spread across the entire network, so it can learn and adapt
Oh, so it's more...
by like changing how strong the connections are.
Gotcha. So not programming specific responses, but letting the system...
Learn.
Right.
Exactly. And McClelland and this guy, David Rumelhart, they created this whole framework called parallel distributed processing,
PDP.
or PDP for short.
Okay.
Basically, it was like a model for cognition based on these networks.
So PDP was like the blueprint for building.
Pretty much. It led to the development of modern neural networks, which are in, well, everything.
Yeah, it's in like everything now.
From Siri to, those AI image generators.
Wait, so those AI image generators everyone's talking about, that comes from PDP.
Yeah, it all goes back to that.
That's wild.
And it's not just the tech itself. McClelland really changed how everyone thought about AI research.
Oh, wow.
PDP kind of opened the door for all these different ways machines can learn.
Like how?
Like supervised learning, where you feed the system labeled data, unsupervised, where it figures out patterns on its own.
Right.
And reinforcement learning, where it learns through trial and error.
So all those different types of machine learning, it all comes back to...
To McClelland's work with PDP, yeah.
That's huge. It's not just AI though, right?
Yeah.
Wasn't there something about his work being relevant to how our brains work too?
Oh yeah, definitely. PDP was a big deal for bridging the gap between AI and neuroscience.
So he wasn't just making better AI, he was also helping us.
Well, yeah, by modeling cognition as a network, it gave us a whole new way to think about how the brain might work.
So McClelland was helping us figure out our own brains. Wow, this is so cool. This is going way deeper than I expected. I want to hear more about how his work is helping us understand the brain.
Oh, yeah. So one of the big things he shed light on is neuroplasticity.
Neuroplasticity.
Yeah, the brain's ability to adapt and change throughout our lives. And his research suggests this might come from the same kind of connection-strengthening processes that power learning in those AI networks we were talking about.
So it's like our brains are rewiring themselves all the time based on what we experience. Kind of like how AI systems learn from data.
Exactly.
Jeez.
And the more we learn about this, the better we can get at treating neurological disorders, improving memory, and even making our brains work better.
Wow. The implications are huge.
Right.
So McClelland's work is shaping AI, but also neuroscience and like what it means to be human.
Yeah, it really is.
This is incredible.
It is, right?
Okay, before we get too deep into that, I remember something in the article about McClelland's work on,
Oh, yeah.
what's it called, predictive coding?
Yeah, predictive coding.
Yeah. What's that all about?
Well, it's something he's been really focused on lately, and it builds on this whole idea of the brain as a network. Basically, it says our brains are always making predictions about the world based on what we've experienced before.
Okay.
And then updating those predictions as we get new information.
So like our brains are always trying to guess what's going to happen next.
Exactly.
And that's how we make sense of the world.
It's how we catch a ball, understand language, even just walk through a crowded room without bumping into everything.
So is McClelland trying to like build AI that can make predictions like our brains do?
He is.
Wow.
And if he can do it, it could revolutionize AI. Imagine AI that can see problems coming, learn from way less data, and interact with the world in a way that's just
More natural.
more natural, yeah.
That's amazing. But how does predictive coding even work?
Yeah.
Seems pretty complicated to replicate in a machine.
Oh, it's definitely complex.
Yeah.
But they're making progress. One of the key things is that the brain isn't just processing information. It's actively trying to predict what's coming next.
So it's not just reacting, it's like anticipating.
Yeah, exactly.
How does that even happen in the brain?
Well, it's a whole interplay between different parts of the brain.
Okay.
You've got these higher level areas making predictions based on your past, and lower level areas processing what you're sensing right now.
Okay, so the higher level areas are like the prediction engine, and the lower level areas are checking if those predictions are right.
Exactly. And when there's a mismatch, like the prediction's wrong,
Right.
that creates an error signal.
Okay.
And the brain uses that signal to update the predictions for next time.
So it's like a constant refinement. Yeah.
Wow, this is amazing. So by figuring out predictive coding, we can build better AI and also learn more about how our brains learn and adapt.
Exactly.
This is blowing my mind. It's pretty wild, right? And this is just one example of how McClelland is pushing the limits of AI and neuroscience. He's actually trying to build these predictive coding ideas into AI models now. Could lead to some incredible AI in the future.
AI that's like even more flexible and adaptable.
And even creative.
Oh, creative AI. That's a whole other...
I don't know.
It seems like McClelland is always pushing the limits of what we thought was possible. What else is he working on now?
Well, another really interesting area is incorporating what he calls biological constraints into AI models.
Biological constraints? What does that even mean?
It means basically looking at how the brain works and using that to design better AI systems.
So instead of just trying to build AI from scratch, he's looking at the brain for like clues.
Exactly. I mean, the brain is this incredibly efficient information processing system. It's been evolving for millions of years. If we can figure out its principles, we can probably overcome some of the limitations of AI now.
What kind of limitations?
Well, right now, AI needs tons of data to learn, and it struggles with things that seem easy for us, like common sense reasoning or understanding complex relationships.
So by using these biological constraints, could we make AI that's like more efficient, needs less data, and can handle more complex stuff?
Exactly. And that could lead to huge breakthroughs in all sorts of fields. Robotics, natural language processing, even scientific discovery.
Wow. So studying the brain can help us unlock possibilities for AI. And studying AI can help us understand the brain better.
It's like this awesome cycle.
It is. It's incredible. Think about all this. But with all this talk about smarter machines and the brain and everything, it makes you wonder.
It does, doesn't it?
Yeah.
Where does all this lead?
Exactly. Where does it all lead?
Right.
Like, where does all this lead? What's the big takeaway from all this?
Well, I think McClelland's work shows us that we're still just scratching the surface when it comes to understanding intelligence, you know, whether it's artificial or our own brains. There's so much we don't know yet. And the big breakthroughs, they often come from places you'd never expect.
So we shouldn't get too comfortable thinking we've got it all figured out.
Exactly. We got to stay curious, keep exploring, and be open to new ideas. And I think one of the biggest lessons here is don't underestimate the power of like thinking across different fields.
Right, like McClelland did with AI and neuroscience.
Exactly. Combining those insights, that's where the real magic happens.
And who knows what other connections are out there waiting to be discovered.
Right. Maybe the key to consciousness is hiding somewhere in physics or philosophy.
Or me.
Or maybe we'll unlock the next level of AI by studying, like, slime molds. Who knows?
Okay, now you're really blowing my mind.
Yeah.
But I like it. So someone listening who's, like, totally into AI and wants to learn more, where should they start?
Well, I definitely recommend checking out more of McClelland's work. His research is groundbreaking, but it's also surprisingly easy to understand, even if you're not a tech expert.
And who knows, maybe they'll be inspired to contribute to the field themselves.
Exactly. Whether it's, you know, developing new algorithms, doing research on the brain, or even just thinking about the philosophical implications of AI.
Right.
There's a place for everyone in this. It's an incredible journey.
Well said. I think it's safe to say this deep dive has given me a whole new perspective on AI and how it can impact, well, everything. Not just our technology, but how we see ourselves in the world.
It's been great exploring these ideas with you. I hope it sparks some curiosity in our listeners.
I hope so, too.
And a desire to, you know, keep digging deeper into the mysteries of the mind and what AI could become.
Absolutely. Thanks for joining us on this deep dive. It really does make you think. So where do we even go from here? What's the What's the takeaway for our listener?
I think McClelland's work shows us, the quest to understand intelligence, whether it's artificial or biological.
Right.
It's a journey, full of surprises. And sometimes those breakthroughs, they come from the most unexpected places.
So we shouldn't get too stuck in our ways, thinking we've got it all figured out.
Exactly. Got to stay curious, keep exploring, and be open to new ideas, And I think one of the biggest lessons here, don't underestimate the power of thinking across different fields.
Right, like what McClelland did with AI and neuroscience.
Exactly. Combining those insights from different fields, that's where the magic happens.
And who knows what other connections are out there just waiting to be discovered.
Right. Maybe the key to understanding consciousness is hidden somewhere in physics or philosophy or maybe the next big AI breakthrough will come from studying slime molds.
Okay, now that's just wild. But I like it. So someone listening who's totally fascinated by AI and wants to learn more, where should they even begin?
Well, diving deeper into McClelland's work is a great place to start. It's groundbreaking stuff, but it's also surprisingly easy to understand, even if you're not a tech expert.
And hey, maybe they'll even be inspired to, make their own contribution to the field.
Absolutely. Whether it's, developing new AI algorithms or doing research in neuroscience or even just thinking about the philosophical implications of all this.
Right.
There's a place for everyone in this journey. It's incredible.
That's a great point. Well, it's safe to say this deep dive has given me a whole new perspective on AI and its potential. Not just for technology, but for how we understand ourselves and the world around us.
It's been awesome exploring these ideas with you. I hope it's sparked some curiosity and maybe a desire to delve even deeper into, the mysteries of the mind and the possibilities of intelligent machines.
Couldn't have said it better myself. Thanks for joining us for this deep dive. And until next time, keep exploring, keep learning, and keep asking those big questions.